Hi, my name is Tyler Shake, representing Group 1, and this is Video Update 5. I'd like to begin with what all we've accomplished since the last video update. We have acquired new motors. These motors are more powerful, and they also come with bigger wheels. We have mounted those to the robot, and they seem to be firing much better than the previous motors. We have built an amplifier circuit, uh, actually 3 amplifiers, to control the release servo, the base servo, and one amplifier circuit will go to the two motors attached to the wheels that will shoot the ball. We have created a ball hopper to hold the balls, and we have mounted the release servo. We've acquired quite a bit of technical problems with trying to integrate the entire system, so I'd like to talk about those now. Whenever the power source was turned on, but no signal, the program was not running at all, the amplifier circuits would actually send minus 11 volts to both the base servo and to the motors, causing the base servo to just swing to the left. And what ended up happening is it actually damaged the base servo. It grinded some gears. So we had to take apart the servo, and we had a couple of leftover servos laying around. We just replaced the gears and put it back on. And we obviously disconnected the servo from the amplifier circuit and tried to figure out why it was sending this minus 11 volts. What we ended up figuring out is that the input into the amplifier needed to be connected to the Q4 board so that the signal was grounded so that it would not send the minus 11 volts into the servo and damage it. So once we hooked up the input to the Q4 board, we no longer had that problem. Another problem that we encountered was after we had it all hooked up and we'd turn on the power source and we'd run the program, it would run for about half seconds and the power source would actually shut off via some kind of safety switch. We figured that having all those things run at once was drawing too much out of the power source. So in order to fix that, we had to completely modify our block diagram. We added a couple of switches to the block diagram so that both the base servo and the release servo were not running at the same time. The way the procedure worked is the base servo would begin on and the release servo would begin off. We would run the program, the base servo would move, the motors would speed up to their appropriate speeds, we would turn off the base servo via a switch, we would turn on the release servo via a switch, then the balls would be released, fire through the wheels and into the cup, and then we would turn off the release servo and turn back on the base servo. And by doing that, we no longer had the problem of having the power source just shut off. There's a couple of times that we broke a couple of servos by hooking up the wrong ends of the motor. We had to just basically take it apart and replace the gears and put it back together and reverse the polarities on the motors driving the servo so that we did not have the problem of trying to go the long way, so to say, around the circle to approach the desired trajectory angle. As for how are we on schedule, we are behind schedule. We were hoping to have everything integrated and functioning properly last week, but having to order new wheels and troubleshoot problems that we have encountered, we have just now established having everything integrated, and we still have to calibrate and test to see how consistent the machine is shooting. So the plan is to spend a lot of time this weekend before the final demonstration calibrating to see if we can get this machine to shoot consistently. My expectations are similar to how they were earlier. We had originally just hooked up the DC power supplies in the lab to the motors and just tried testing to see how consistent the ball was shooting, even attached to the release servo. and we'd pick a cup to aim for, and you'd hit the cup every time, but it wouldn't always go in. So we were having some inconsistencies with the shot, whether it be because the motors weren't mounted perfectly, the dowel track leading to the motors weren't perfect, we didn't have any control on the motors, so we were not entirely sure that they were spinning at the same speed. The balls could have irregularities um, amongst them. I mean, there's a lot of variables. So, I mean, my expectations are that the closer cups are going to be much easier to hit than the further away cups. So, I'm hoping that